Then I have more diagrams here. So part C. Sorry. Look something like that, where this is P, this is C, this is Q, this is E, and they've told me that all of that there is, now I need to be careful here, 32 minutes. It's not even a degree. 32 minutes, 4 seconds. Okay, so 0, 4 there. And what they want me to do is, so they talk about an observer on the equator measures an angle from one visible edge of the sun to the other opposite visible edge of the sun as shown. The diagram is not to scale. Prove that the angle PEC is equal to the angle QEC. Well, I have right angles there because I have tangents. I have that is the same as that because they're both the radius. And then obviously that is the same as that. So the line EC in this triangle is the same as the line EC in this triangle. So it looks like I can prove congruency. So I'm just going to write that down. So I have the angle EPC is equal to the angle EQC because they're both 90 degrees. Okay, I'm going to make, every time I make a statement, I'm going to have to back myself up here. CP, the length of it, is equal to the length of CQ because they're both radius, both the radius. And this line here is common. EC is equal to EC, common line. Which means the triangles are congruent. The triangle EPC is congruent to the triangle ECQ because of a right angle. The hypotenuse are the same, and another side. So we're looking at RHS here. That's my reason for congruency. So I know that this top triangle is exactly the same as this bottom triangle. Therefore, my two triangles are congruent. Therefore, I've proved that the angle PEC is equal to the angle QEC. And see part 2. Hence, using your answer from part B above, find the radius of the sun correct to the nearest kilometre. So we're looking for R here in my diagram, the radius of the sun. And what do I know? I know the angle PEQ was 0 degrees, 32 minutes and 4 seconds, which means the angle PEC is equal to 0 degrees, 16 minutes and 2 seconds. So I know that this little bit here is 16 minutes, 2 seconds. And from that, looks like, okay, so I can, do I have this distance from before? I do. I know that this distance here to the edge of the sun is 149,643,628. So I know the length from there to there from the previous question, plus the R would give me that. So now we're looking at, if this is the angle we're using, we're looking at sine again, because it's opposite over hypotenuse. So the sine of 16 minutes and 2 seconds is equal to r all over 49643,628 plus r. And we just need to work this out. So we have the sine of 0 degrees, 16 minutes and 2 seconds. Now I'm going to save that, store that as A. Okay, and I'm going to bring this over, it becomes multiply, so it's the sine of 16 minutes 2 seconds times 149 plus r is equal to r. This is actually quite similar to earlier on in the question, a bit tedious with all the decimal places, but so I'm going to multiply this by this. So I've stored it as A, and I need to multiply it by 149,643,628. And I'm going to store that as B. So 697,921.52255. That's stored as B plus the sine of 16 degrees or minutes 2 seconds times r is equal to r. I'm going to bring this over. So I have 697 ... is equal to r minus the sine of 16 minutes 2 seconds times r. I'm going to take the r out in common. I'm left with 1 minus the sine of 16 degrees 2 seconds is equal to 697,921.5255. And I'm going to divide by this. So I have this stored in my calculator as A. So I'm just going to go 1 minus A. And I'm going to store it as C. So that's R times 0.99533361093 is equal to the 697,921.5255, which I've stored as B in my calculator. I need to bring this over. It becomes division. Just going to store it as C, and I have B divided by C is equal to R, so B divided by C is equal to R is equal to 701,191.8075, and they told me to round off to the nearest kilometre. R is equal to 701,902 kilometres.